Live from New York, it's Ask an Engineer.
Hi, everybody. It's me, Lady Ada, with me, Mr. Lady Ada, streaming here from downtown Manhattan in the secret Adafruit extra headquarters. Manhattan is where we do all our manufacturing. We make electronics for the world around, and I do some of those designs here. But for the next hour, we're going to check in what's going on in the community. What's the news? What's the products? What's the secrets? What's the NPIs? What's the retro tech? We've got a lot of cool stuff to show off for about 1 hour. Thanks for being patient. We had a massive show and
Yeah,
tell
so
to
tell us
talk about. Mr. Lenita, why don't you get the AGI in?
the code tonight is DVI Bell, and it's because we have a lot of neat things that you can do with the Feather DVI, including something like what we do. This is live graphics being pumped out of a Feather DVI, and I'm just changing some of the things that the video tool that I use with the colors that are coming in. So this
Yeah.
is just like, playing with hue or contrast or whatever. And you can see this is
Oh, wait, this is cool.
our backgrounds. And so the phrase "eat your own dog food," which doesn't make sense. You wouldn't eat your own dog food if you work at a dog food factory, unless you were maybe a dog there. Um,
That's true. What if there's a
if
doctor?
you're a dog there, but we like the idea of using these tools with our shows and more. So this is kind of neat. This is some art that's just going to go in the background, and when we're doing stuff, we'll just have it very Max Headroom
I
esque.
like it. And it's Ada for code.
Timely, because the code is DVI Bell, 10% off the native store all the way up to 11:59 p.m. tonight. We'll talk about some of our live shows, including Show and Tell. We just did that a few moments ago. We'll talk about Desk of LadyAda, where we had a great search. Little JP's product pick of the week. We have some time travel and some help wanted. Some retro tech, which is kind of neat. We've got a really neat video from Adafruit Factory, some 3D printing. INMPI this week, it's going to be Texas Instruments. We have a big old top secret. We're going to answer your questions. We do some new products, all that and more on, you guessed it, Ask an Engineer.
Wow.
Yeah, so let's just jump right in, Lady Ada. The code is DVI Bell. If folks want, they get free stuff. As they add stuff to their cart, they'll either get a Perma Proto or the KP
KB 2040. That's
2040 is back, or
free
free
shipping.
UPS ground, which you should get
199.
anyways.
Yep.
Let's jump right into our live shows. I need to add some sound to this. I'm adding little bits of sound in front of some of these.
Yeah, we're gonna do it.
Yeah. So for our live show this week,
You can do the clip of it. We're gonna do this live.
yeah, no, I am. I'm gonna get the Bill O'Reilly thing where he had a meltdown with "Do it live,
But you're gonna do like the
do it
like
live,
EDM DJ mix.
do it live." Um, I saw this little video of a parrot, and this parrot's like, "I'm not gonna hurt you," and they're like, "You're gonna hurt me." He's like, I'm not gonna hurt you." And of course, they put their hand out, and
Right.
then the parrot hurt them.
Yeah. Well, what's
Um,
funny is that like the parrot, if you're a parrot and you want to bite hands, that's exactly what you should
you
say.
should say, "I'm not gonna hurt you."
Or you should say, "I'm going to hurt you," because people are like, "Really?" And then they'll stick their hand
I'm
in.
in peace.
Either way.
So on the show and tell, it's pretty massive. We had a bunch of demos that use the Feather DVI.
Mhm.
And then you can watch the rest of the show. I have no, I'm not supposed to have
Never a
favorites.
favorite, but
However,
a
however,
highlight.
however, one of the projects I really liked this week was Deshipu stopped by different times that I've seen Deshipu in live in a while.
Yeah.
But a lot of cool crab robots.
Crab bots.
And I think it was a couple weeks ago, I saw some type of like video show documentary thing about how like everything eventually turns into a crab in nature. So this kind of just confirms that. But really neat little crab robots using CircuitPython and more. And you can check out those on Hackaday.io, Deshipu's Hackaday.io. And Delchi had a really neat, super modded hacker wheelchair. It was,
Yeah, it's cool LEDs, and it's got like star effects, and it's got a sound system, a good hacking.
And then DJ Devin had a really good example of all the different things you can mush together with the Feather DVI and weather and
Do a
data.
sensor
Yeah.
on-screen display, which is a really good idea. It's like very hard to do on-screen display stuff.
Yeah. So that was really neat. So anyways, check it out.
Mhm.
It's probably on all the places we just broadcast to. On Sunday, as we do from the desk of Lady Ada, it goes in two parts. Lady Ada, what did you talk about in part one this week?
Okay, so this week, one of the things that I worked on is the Circuit Pirate, which is an old design from like 7 years ago that I was like, yeah, I'm going to revitalize this design because the Bus Pirate, which we've stocked for over a decade, is no longer available, probably because of part shortages. So we looked at the original design of the bus pirate and showed how to kind of like modernize it, maybe turn it into RP 2040, but still maintain some of the compatibility, especially with the 5-volt compliant inputs, which is one of the cool things about the bus pirate. So we talked about how the bus pirate did that, and then how I'm adapting it to work with the circuit pirate, which is RP 2040 based.
Okay. And then on Desk of LadyAda, we also have The Great Search, which is getting easier and more fun because we can actually get parts now.
Yes, I'm actually enjoying it. It's no longer
Yeah.
just like let's get
It
replacement
wasn't
parts.
it wasn't a downer everywhere. It's like, well, like here's another substitution search because on planet Earth we have no cobalt right now or something. So what did you help people find this week?
Okay, so this week what we did is the way that the original Bus Pirate handled different voltage levels, it actually used an analog switch, which is a really cool hack because it wanted to switch in different voltages of pull-ups. So, 1.8 volts, 3.3 volts, 5 volts, and it used a 4066 analog switch. So I showed off all different kinds of 4066s, analog switches, 74 series, ones that would work with lower voltage, higher voltages, as well as different analog multiplexers that are available on the market. They're very useful. You can get ones that are very high speed, you can get ones that are high power. The 4066 is inexpensive and kind of middle of the road, but does the job quite well. And then also we linked to an interview with Ian Lesnay, Lene, who did a interview about how that part of the circuitry was designed and why he picked those components. It's not an accident. It was done on purpose. So check out this Desk of LadyAda, great search, and also the text that we posted on the blog.
Okay, and then every Tuesday we have JP's product pick of the week broadcast live from the product page. Here is this week's highlight.
Hey, there we go. That's my product pick of the week this week. It is the Matrix Portal. We've now got GIF support. So this is the first time I've used GIF I/O on the Matrix Portal with a Matrix display. The nice thing is this display just basically shows up in display I/O. So look at that right there. There is one of our panels with the Matrix Portal right there. I've got it dark at the moment so you can see the colors a little better. Running a little animated GIF. This is I don't know, I think something like a 40-something frame GIF, so it's not tiny, but it plays back great. It plays back really nice and fast. Look at those great colors. Built a little Lego frame for it. And around the back you can see there is my Matrix Portal plugged in. Got bunches of different kinds of, from wee little 32 by 32 ones. This is 32 by 64. Right there is my product pick of the week this week. It is the Matrix Portal.
All right, and don't forget tomorrow is JP's workshop, and then Friday it's deep dive with Tim.
Gonna go back in time. Gonna go back in time. Gonna go back in time.
All right, some time travel. So we're gonna just do some news and more from around the web. We have a job that we just posted on the Adafruit site. So yeah, so I'll go
I need somebody.
help wanted section here. So on the Adafruit site, go over to jobs board. So if you go to adafruit.com/careers, we're looking, this is an on-site position. So this is someone who would be in New York City. We need an arrivals process stage manager and manager in a receiving group. Just to give everyone, this is, kind of a typical receiving job in a company that ships goods and gets goods. But just to give you a little, state of the economy for Adafruit. So we're still hiring and our teams are still getting raises and all that. I understand though, especially the tech sector, there's pretty large layoffs, lots of publicly held companies. And then today Microsoft said, no more raises, no more bonuses. There's something going on with like the return to work and the kind of like this post-COVID thing. We haven't been hit like that. We're still recovering from 3 years of just like everything coming up, including the part shortage, but we're doing pretty good. We're really looking forward to shipping AdaBox, and then we have a lot of things planned, but we're still doing good. We're still hiring. So check it out. We have a really good benefits offering.
Great team.
Paid time off for charity. Things that would matter to me
401k matching?
Yeah, well, the other thing is there isn't like executives and then
Oh,
everybody
you get the
else.
same healthcare I've got.
Yeah, so
Same 401k I've
we
got.
decided a long time ago, when you join, you get the same benefits that even the founder has. So that's really important to us.
Same exact healthcare, same dental, same vision.
Yeah, I think for 401k, and it was interesting when we did all this and we were talking to all the healthcare brokers and like the 401k brokers, they basically called us socialists.
That's
But
right.
anyways, so join
Mine didn't really want to work with us anymore.
join us, comrades. So anyways, you could check it out on adafruit.com/job.
Yes.
Okay, some retro time. Okay, this week's retro set of photos is, we didn't get to it in March, the Marcintosh thing, but that's okay.
Hey,
Do you know what this is, Lady?
this is the e-mate.
Yeah, did you have one of these?
I never did, but it was definitely like
Where were you
weird.
Where were you 26 years ago? Where were you in 1997?
97. I was in high school.
So you were in high school, so you probably didn't need one of these at the time, or maybe you did. Maybe did you know about it in high
I
school?
heard about it, and it was definitely. I think this was during like the PowerPC era, and I was kind of like not as into Macs at the time. I had a PowerBook 540C, but I think that came out a little bit later.
So it had this translucent plastic. It came out.
I think it was like a kid's toy. I was like a little bit
It
like,
looks like it's ours.
like,
Yeah.
what is
So it
this?
came out in March of '97. It was about $800, so that'd be like $1,400 now. It had an ARM 710A, 25 megahertz. Had 1 megabyte of memory, expandable to 4 megabytes. Storage 3 megabytes. Display was 480 by 320. This is basically a Circuit Python computer that we're probably gonna end up having.
25 megahertz. I mean, yeah.
We'll be able to reproduce a lot of functionality. The only Newton that had a built-in keyboard, you could get keyboard
Yeah,
accessories.
this was like a super Newton. I really just wanted like a PowerBook, so I got a PowerBook instead.
Yeah, it had an internal memory expansion slot inside of it. You had to, get inside of it, and kind of neat. It was meant for classrooms. It it got canceled in 1998, along with the entire Apple.
It did not last very
Product line.
long. Yeah.
But I like this aesthetic. It's really nice, and ours works. So this
It's
is
very cool.
yeah. So that's
It's a very interesting style. I mean, it was like, they did like the candy clamshells as well. Did they do some other candy clamshell?
Well, the MacBooks. You remember the little iMac?
Yeah,
the
yeah.
iBooks, the iBooks.
The iBooks, yes. So that was like the same timeline, right?
No,
No?
I don't think so.
Hmm.
I think this was before that.
Reminiscent though. This was before then, but I think it's like
Yeah,
that design stuff.
yeah. I think they were like, well, we still like this idea. So
It's cool translucency.
yeah, it's kind of cool. All right, that's retro for the week. Okay, Python on hardware. I thought this week we'd go over a couple things, LadyAda. The newsletter has so much stuff, and usually we pick one thing. This week we're just going to do a smattering. So if you're someone who uses Raspberry Pi, there's an update. It has the new Linux kernel, so that might be something.
Long-term support.
Yeah, that might be something that you want to do. It also has the latest update with MATLAB. We try to use the newsletter for events that we know the people who read the newsletter. So KeyCon or KaiCon. It's
Yes.
yeah. Either one is fine. But it'll be September 9th to 10th this year. So if you use the open source CAD tool, check it out. We're probably going to sponsor or do something in some way. There's a post about CircuitPython and version control. If you want to use some type of version control.
Yeah, it's like, but you're still on the disk drive. It kind of manages the
Yeah.
file movements for you.
And then for folks who've been using Python with a block editor like EduBlocks, Anaconda acquired EduBlocks. Big news in the maker world if you're into that. And then I thought I would spend a moment on this. And then I'll go through a couple other ones. But what's the best language for microcontrollers? MicroPython, CircuitPython, Arduino RC. I think in general, these type of comparisons are bad because
They are bad.
and I'm going to say like bad as far as it brings out the bad in people because it gets very territorial. It's like no, see or die. Um,
Weird engineerism that it's like there has to
yeah,
be the best. It's like
yeah,
it's like that's not how
and
it
some
works.
people will do a drive-by and just be like, Python on microcontrollers, die.
Or like a
So
hey Arduino.
yeah, yeah, pot smoker for baby language for pot smoker, um, which is what Arduino was called a long time ago. And I did that. I put that quote in my article, and the guy Arn didn't like that. So because apparently at the time Arduino was too dumbed down for people.
Well, if you think that's dumbed down,
Yeah,
running a scripting language on my controller will like explode
yeah.
his head.
So here's what I would propose because I do
Actually,
think
let's track down that guy. Ask him what he thinks about CircuitPython.
it's not good. It's too easy. You're making it's too easy. So one of the things that I think that would be helpful, and we can't do this because we're Adafruit, is I do think it'd be neat to take a project and say, okay, we wanted to have a water sensor alert our phone when there was a flood in our basement. And then from the very beginning, just like kind of choose whatever hardware you want. Maybe everybody has to use a ESP.
Budget of $50.
Everybody has to use ESP32S2 because everything's supported on that. You can use Arduino, you can use MicroPython, CircuitPython, and I think what would be better is how fast can you do it? How much fun can you have? How much time do you actually need to spend to do that project? Because I think that's one of the things that we should measure. What is better to use than something else, not because the language is better, it's just because it's more suited. For instance, if you're going to do things where like you're getting strings of text on the internet, Python's probably it's probably better because it's faster because there are these batteries included libraries. So I think that might be a subtle change. Instead of which is the best language, is like what's the fastest way to get your project going, because there's a lot of times where you want to have like, oh, I just want it to text my phone when my basement's flooding. That's it. That's all I want to do. And the best language isn't probably going to be the fastest language, because best is subjective, but fastest, I think we can all agree. Some of them are faster than others as far as getting the project done. Not the speed, like, oh, how many milliseconds, but how long does it take you to get the project going? Like, there's certain bits of hardware like Stemma that makes things easier. There's certain things like Python libraries that make things easier. So I think that would be a way to go. Another example is like, so MakeCode could be in this list because there's a lot of projects that are like, if you I just want to do some swirly things with LEDs really fast for a costume. MakeCode, almost instant. Is it the best language? Depending on who you ask, like, there's internet jerks that are going to say, yeah, you should use machine code, assembler, whatever. I don't understand why they use Twitter if that's the best language. Anyways, so I think that's just a slight different way of looking at these things. Anyways, you can check out the rest of the projects and more. I like this universal computer thing.
Which is cute.
Yeah, speaking of the eMate, this is kind of
eMate too.
This is what it reminded me of.
PyMate.
Yeah, and then someone in chat just did Prime's drag race. I like the idea of drag race. Maybe we could like drag race would be a term for you set out what the project is and then who can get the project done fastest, and then you look at what they used. That'd be kind of cool. Anyway, so that's our Python on Hardware newsletter this week. One other little reminder, happy birthday MicroPython turned 10. I've known out to Damien, we're going to do a donation. We already do stuff with GitHub sponsorship. If you use MicroPython, send them a buck or two. It's what CircuitPython's based on. We deliver this newsletter every single week in your inbox. Adafruitdaily.com. We don't spam you. We don't do anything other than send you the email once a week. Let's do some open source hardware, LadyAda. We're an open source hardware company. To prove it, not only do we certify our hardware, because you can do that, we have a bunch of guides.
That's right.
What's on the big board this week?
Okay. I'm back to reviewing guides, so some of them are taking a little bit longer than normal to get to the front page, but we did get a bunch done this week. So the guide for the Adafruit Pico Bell CAN bus for Pico, that's a couple weeks, part from a couple weeks ago. Liz, who's been doing a ton of the guides for the Pico bells, made this live. So it's an MCP 2515 CAN bus controller. Really handy if you want to use your Raspberry Pi Pico or Pico W with CAN bus interfacing. We make it super, super easy. We got example code for Arduino and CircuitPython, and I'm sure there's MicroPython drivers as well. The Feather RP20 Think Ink, that's our RP2040 Feather, that's all built in, ready to go, and even has an EPD, electronic paper display connector on it. So almost all displays that use 24-pin connector, pin FPC cables, you can plug it in. Again, we've got drivers in Arduino and CircuitPython. There's also MicroPython drivers as well, so you're totally free to use that. We also have U2IF driver support, which means you can actually code an e-ink display from your computer, and it will control it through USB. So very handy if you want to have very complicated graphics and data parsing, and you don't want to run on a microcontroller, you want to run on a computer, but you just need a little gateway device that'll get the e-ink display interfacing with your machine. Robert Smith, not of The Cure, but we wish, but also he's as cool as Robert.
It's funny. I wish for something, and this is how it happened. I'm like, man,
you know what? He's got better.
I'm like, I wish I could do a project with Robert Smith, and we are.
Yes.
Yeah.
This is a Fisher Price USB controller. So he did this project, and it was like we were going to this project, and he did it before we did it, and so it, like, saved us that time. So it's a really, really good guide on how to take this Fisher Price USB gate toy, which does not do anything, right? It just has buttons. But he opened it up and he's like, oh my God, they actually have elastomers for each key. Like it could actually do something because it's not fake. Like most kids' toys are fake buttons, but these are real. Tapped into the copper traces. And oh wow, he's even got a video.
Yeah, on Twitter right now, Robert's doing a giveaway, and you just have to post up like what other what other controller you want to see have. So I grabbed this really fast. You can see it's 3 minutes long, but it's sped up, and you can see all the Adafruit stuff.
So you see, there's actually a circuit board. I mean, it makes like audio clips and like lights up and stuff. So you can tap in with a KB2040 and then using QMK or CircuitPython or Arduino, whatever, turn it into an actual gamepad. So either gamepad or keyboard. And he shows how to do it. He did a really great job. And this is
now that we have a kid, I'm not doing Hackaday, that's the site I started. I'm not doing Make, but if I were to write an article and kind of make a big statement, I would say drop everything, go buy kids' toys, and use those as project enclosures because they all have screws. Because otherwise babies would choke. So you have to unscrew everything. Sealed electronics is not great, but these all have batteries, and the enclosures are great. They're battle tested, and then there's lots of room inside of them, and like. You can get these for cheap. So brand new, it's like $6 on Amazon. You have like a game controller that can be turned into this. So
it's actually cheaper than like most game controllers.
Yeah.
And somebody apparently won some, like there was a gaming contest and somebody entered using this as their game controller. And see everyone else has got this like Steam controller, whatever, with magnetics. And he's like a chunk, and it's like making, it's like octagon, purple, blue, you know.
So check out all, we have it up.
Okay.
It's a cool project.
Cool. So that's that. From Noe and Pedro, this week's 3D project is a Bo-Katan inspired 3D headband. No coding on this one. And then can you scroll down? I think there's a couple more new stuff. We've got and it's updated the Adafruit Playground Notes. That's what we're calling user-generated content that uses Adafruit Learn's editor. We've also got the guide for the CAN bus feather wing. So again, if you want to use CAN bus MCP2515 with any of our feathers, this product is many years old, got delayed by the component shortages, but is you see all the CAN bus stuff was waiting until I could get it. Now it's all out. We have an update to the Adafruit Penguin guide. All of our new boards, including some of our old boards, when I revise them, they're using Penguin to get really beautiful graphics. And this has been updated. We now also have support for like dynamically entering in bitmap images, which if anyone has used import bitmap on EagleCAD, you know what a nightmare it is because you're always like, well, how big do I want it? And you're dividing the DPI by like the size, whatever. Now you just draw a rectangle and you name the group of the rectangle. It's like a right click and you just name the group, whatever, Adafruit.bmp, and then when you run Penguin, it will automatically raster the graphic and fit it within the boundaries of the square. So just fit, however big you want it, and it will pop it in perfectly for you. And so I'm using that now. It's saving me a ton of time because I'm not doing this constant import, export, resizing, whatever. And it works great. So check that out. It's tested and now documented. And then JP did this really cool desktop out card display. I think this guide went live.
Yeah, we should also. We showed
We
the
showed it,
video.
but the
We showed the
guide
video.
the
Yeah.
guide is now live. So if you have, he's going to show also how to make an actual Alcar's display overlay. This one
Yeah.
is an official prop from the Picard show because his friend works on the show. But a very cool demonstration of how to use the Matrix portal to light up different segments of a acrylic panel.
All right, I'm gonna play this video from Liz. This is a DVI demo, and then we'll go into a fun manufacturing video. What we do.
In this project, you'll use a Feather RP2040 with DVI output to build a fun and funky video synth. The Feather runs Arduino code, written with the Adafruit fork of the Pico DVI library. 5 animations are available on the synth. You can switch between them with the press of a button. 4 potentiometers control the RGB values and speed in the animations, so you can dial in the perfect pixelated vibe. The shebang button unleashes glitchy and unruly Easter eggs for each animation, ranging from randomness to simulated black holes. All you need is USB power and an HDMI monitor to start visually vibing with shapes, colors, and static. To see how you can build your own, check out the Learn Guide at learn.adafruit.com.
And here's some factory footage. And that was celebrating Made in NYC, which is going on. And this week, it's a bunch of companies and more in New York City that kind of show what they make. Let's do some 3D printing. We're going to play this week's video from and Pedro. I speed up as well, so we'll see you on the other side.
You can make a 3D printed LED headband inspired by Bo-Katan from Star Wars. This design features engraved details that wrap around the headband and uses an adjustable strap to fit comfortably over your head. The LEDs are powered by a coin cell breakout hidden inside a 3D printed battery box on the end of the strap. These miniature LEDs come in a few different colors and they're pre-wired, so they're great for prop builders and model makers. The Adafruit coin cell breakout features an on and off switch, header pins, and mounting holes for securing to your projects. Download the free CAD files and 3D print them in your favorite filaments. The design is open source, so you can customize the headband to fit perfectly over your head. The wired LEDs are threaded through the built-in recesses and hot glued in place to create a DIY diffuser. Once it's cooled down, you can use a hobby knife to trim away the excess and square it up so it looks nice and clean. Solder the blue wires to the ground pins and the red wires to the switch's power pin. Thread the elastic strap through the slits on the side of the headband and add a metal clip to the ends to keep it fitted. The strap can then be threaded through the battery case and the breakout board is secured with machine screws. The CR2023 coin cell fits into the breakout and should last for several hours. This chonky button actuator press fits into the top cover and gives you much better access to the breakout board's slide switch. Snap fit the cover over the case with the LED wires inserted through the built-in slit on the bottom of the cover. The wires are then hidden behind the elastic strap and sewn in place with just a few stitches. We really like these tiny LEDs because they're easy to work with, and we think they're great for making props with embedded lights. We hope this inspires you to add LEDs to your projects, and check out our guides on learn.adafruit.com.
And don't forget, the code is DVI Bell. That'll get you 10% off in the Adafruit store. Let's go do some IMPI.
Okay.
INPI brought to you by DigiKey and Adafruit. This week it's Texas Instruments. LadyAda, what is this week's INPI?
Okay. This week's INPI, I actually was like excited about this because this is the DRV 8411. It's a series of new motor driver chips from TI, and I love their driver chips for motors. It's available in both QFN and TSOP power package, PWP package. Right now, DigiKey only has the QFN in stock, but the TSOPs, I'm assuming, are coming soon. So this is a series, the DRV 8410, 11, and A motor drivers. These are small dual bridge motor drivers. There's two full H bridges. They're low voltage, so they're designed 1.6 volts to about 11 volts DC, and they can drive two brushed DC motors or one stepper motor, bipolar, or you can probably also drive a unipolar, but it's designed for bipolar usage. And it's a powerful driver that is drop-in replaceable. You can see it's pin compatible with the DRV 8833, 8833C, which is a lower power version, as well as a couple other similar chips, the 8847 and the ones in the family, the DRV 8410 and 8411. They've got really low on resistance of only 400 milliohms. They've got, again, low power but wide supply range, 1.5 to 11 volts. You can use, logic levels down to 1.8. So, you've got something running on two AA batteries. It'll work fine. Up to 4 amps peak, which is quite a bit, although we'll chat about some of the constraints of doing that. And particularly I like this because this is pin compatible with the DRV 8833, which we have a breakout for. It's a very popular motor driver chip, and we use it in a couple of different of our designs, not just the breakout, but also the Cricket. Now, if you're wondering, what were we doing about 1 year ago? May 26, 2022, we had a post for the chip shortage. We did a series on this video show called Chip Shortage, where we basically begged for chips because we couldn't get them. And one of the chips I really wanted was the DRV 8833. We did eventually get them. I don't know whether it's because we did this video asking very much if we could get an allocation.
Yeah, there is someone, I think it was on like Hacker News, and they're like influencers. We're not influencers. They're influencers begging for chips online.
That's right. We did. We will do anything to get chips. We could get components.
They were half right. We were begging for chips, but I don't think we influenced much.
Okay. Well, it's a very funny video. You can go back and watch it. We did those almost every week. So the DRV 8833, which is here is shown our breakout board. You can see it's driving a bipolar stepper motor, 4 pins, and again, you can also drive 2 DC motors. I like it. It's just like a general purpose, kind of use it for anything motor driver, which I like. A lot of motor drivers are like only steppers or only bipolar or only unipolar or only one H bridge, but this is like you drop this in, it can do a lot, and it's inexpensive. It's only about $1. So the DRV 88844, the DRV 8411 and the 8410 is kind of the next generation. So this shows you, the TI, this is their portfolio. As the RDS on, the resistance of the built-in H bridge goes down. You can do higher peak current. You have less power dissipation issues. More power is going from your power supply to the motor. So you can see the 8411, the big upgrade from the 8847 and 8833 is much lower voltage support, so you can go down below 2 volts and much higher peak current. The 8847 can go higher voltage, but if you don't need to go above 11, then these chips will do quite a good job for you. They're very simple. Again, unlike some stepper motor drivers, you control the individual H-bridge inputs. You get 4 inputs that you will PWM, and so if you want to do micro stepping, you would actually PWM them to micro step. If you're just doing half or full steps, you can just GPIO toggle the pins up and down. There's false information, so you know if you've reached the current limiting, and you can also put it into sleep mode. There's also the AI-SEN and B-SEN resistors. You can see those on the side. We'll talk about those. Those are the current limiting. But basically, you've got brushed motors, 2 of them, pop them on, step motor, pop them on, good to go. And this is just a simplified version. It does the current regulation and protection for you. Of course, it's got the built-in flyback diodes, so it's very easy to use. You just power it, give it a couple passive components, and you're ready to rock. So there's 3 variations of this device. The 8410, 8411, 8411A. The 8410 is kind of the most similar to the DRV 8833 in current limitations, and it's also pin-to-pin compatible, which I really like. You can just drop this in place. The 8411A is kind of interesting in which it updates from using external feedback resistances to using a current mirror, which we'll talk about in a bit, which is quite nice. The 8411, 8411A, basically, do you need pin-to-pin compatibility with the old chips? Use the 8411. If you don't need exact drop-in compatibility, I recommend going for the 8411A, which is the NPI I'm actually picking, because again, you can reduce your board bill of material footprint by using the current mirror capabilities. Also, if you need like a really big motor, it does have parallel support. You tie A and B inputs together, and then you tie the A and B outputs together, so you can like have a very powerful output for a single motor. Obviously not for a stepper motor, just for one brushed motor. However, like we said, it's got 4 amps output. You do have to figure out what is the power dissipation. You have to think about it, especially when you're dealing with 4 amps peak. If you're doing 4 amps just once in a while for a second or two, just to turn a motor, to move something, maybe you're good to go. But if you're actually turning it on for a significant amount of time, you will have to calculate your power dissipation. And since these are surface mount chips, not through hole, where it's really easy to like attach if it's a TO220, you can easily attach a heatsink. Heat sinking is not as easy. You can heat sink with the copper pad, the copper ground plate on your circuit board. We'll chat about that in a second. You might have to use also a little miniature heatsink or forced air to get air around to remove the heat from the chip. Looking at the PWP TSOP versus the QFN, they have very similar resistances, but the QFN is going to be a little bit better just because it's got, it's going to be a little bit worse because it's smaller. The TSOP has a nice big heat sinking pad on the bottom. You will have to, of course, connect that to your gigantic ground plane dissipation and then calculate exactly how big of a plane you need. Don't forget to add plenty of vias underneath that thermal pad. It's not optional. Usually that's a mechanical pad. In this case, it's a heat sinking pad. They do have a lot of graphs in the data sheet to check out. Basically, it looks like you really want to have 2 ounce copper. You can get away with 2 layer. the 4-layer will improve, but 2-ounce copper on the outer layers will improve your heat sinking. Again, you're only using the motor here and there, maybe you can get away with it, but the moment you're turning it on for more than 10, 20 seconds, or more than 50% duty cycle, you'll have to think about this. There's also micro heat sinks. The TSOP, I think you can use some thermal paste, put this on. Will it work? There's no heat sinking. The ambient heat sinks at the top is not going to be nearly as good as the bottom. So what you might want to do is actually have the heat sink on the back of the PCB. You expose the ground plane, expose the copper, have it coated with Hassel or ENIG, but still it's open, and then you can attach the heat sink there. So you heat sink through the bottom, not through the top of the chip. So the A version, which I mentioned, the 8411A, does away with this annoyance. So normally you have these big power resistors in there they're the current limiting. So you put them on so you can limit the amount of current. If you don't need 4 amps, you don't want to accidentally pull 4 amps if the motor stalls or shorts. You put these resistors in, and they are actually in line with the H bridge. So you have to connect them to ground for the current to go through the motor and then through these resistors. However, because they're they have to pull that full 1, 2, or 4 amps through them, they need to be really big to handle the heat dissipation because they have a 0.2 volt drop through them. And that's a little bit annoying because you can see they're quite big, and you do have to think about the thermal ramifications of having these current sense resistors that have quite a bit of current through them. And also they're just kind of chunky and expensive. So the A version of this chip does away with that. Instead, there's a current mirror inside. And so there's a transistor inside that's going to do the dissipation for you. Hopefully there's even a multiplier maybe so you don't have, that 0.2 volt drop. And in exchange on the output, you've got what is called A prop I and B prop I, the maybe propagated current limit or current mirror limiting. I don't know. You still need resistors, but they don't need to dissipate the power. They're not in the power path, so you'll still need 0.2 ohm resistors. But they can be 0603 or 402. Really helps reduce the amount of board space you need, and of course you can use that more for your heat sinking ground plane.
Available on DigiGate.
They're in stock, 5,000 of each, the A and non-A QFN type. I'm definitely going to pick some up and do a breakout board. You can see the pricing over here, under $1. So they're price compatible with the DRV 8833, but many improvements. Definitely recommend people check these out and maybe transition your designs. If you're doing revision, this could be a long-term solution.
And that's Ion MPI.
On MPI.
All right, and before we do new products, don't forget the code is DVI Bell. Let's kick it. All right, first up this week, LadyAda is a kit pack.
That's right. Jen Fox has a book coming out later, and there's a project pack that goes with the book. Jen Fox is a friend of the Fruit. She's always doing really cool stuff, and it's awesome to see her publishing tutorials.
Excellent math videos on Instagram, too.
Does great videos. So this kit pack we put together for her to make it really easy for people who pick up the book to follow along. It's got a bunch of components and sensors and alkaline batteries and everything you need. You can buy one now because we have them in the shop, or you can wait till the book is available and maybe we'll have it as a bundle. Next up, from Digital Loggers, these folks are really good at making cool PLCs and relays. We carry the 4-outlet relay, very popular, and they stock this, what they call the Tough Relay. It's kind of neat because it's like, they kind of always, it's like a Galapagos Island. Like they take something that's like, you would be like, oh, it's just a DIN rail mounted relay, but then it has like serial input and the USB. And it's got current measurements, and it can do RH232 or TTL. It's very durable. It's designed for very high cost.
Yeah, it's a tough relay.
It's a tough relay. It's got even the military font thing going, stencil font on there. But some of the cool things is that, again, that current measurement. You can measure the status of how much current is going through it. So it's not just a relay. It's a power management system. You can turn it on or off remotely. You can there's like ADCs. It's kind of like an all-in-one microcontroller slash relay system. Very neat. Check them out. They definitely make stuff that you can't get anywhere else. Like this is sometimes I'm like, oh, this is just a generic thing. A lot of people make it. This is one of a kind. You don't have to DIN rail it, but it does DIN rail if you would like that. And another thing I like is little details. They make the internal blocks removable, so it's easy to plug.
That is nice.
Plug out. Yeah, very nice.
All right, the star of the show tonight, besides you, LadyAda, our team, our customers, everyone who makes this thing go, is something we've been talking about all night.
That's right. The DVI out Pi Cowbell. We're making more Pi Cowbells. You've got a Raspberry Pi Pico or Pico W. You want to add stuff to it. These are the same size and shape. You plug it in, and Bob's your uncle. That's cool stuff. You can get video output.
Look at this.
We have actually now, this is an Arduino demo. This is Arduino drawing to a 320 by 240 16-bit color
Look at this.
frame buffer that is output over DVI, which means you can plug it into any HDMI monitor. You got your Pico.
This is the demo everyone likes.
You want sprites drawing. You want flying toasters. You want a after dark aquarium. We've got that as well. You want
I want to zoom in on.
You want to
this.
zoom in on the
I
toasters.
want to zoom in on the toasters.
Go into the toasters. Zoom in. That's the aquarium.
All right.
Toasters. There you go. All output from the Raspberry Pi Pico because it's got these PIO and secondary core, and you can have that do this DVI bit banging. Very neat. So you've got support in Arduino that uses this frame buffer, and this is all these demos were in Arduino. So it's in the Pico DVI fork. That's in the tutorial. We also actually, as of like last week, have CircuitPython support as well. So if you would like to have CircuitPython running on your Pico or your Pico W and also draw to a DVI HDMI monitor, you can do it. And we're trying to see people do like cool, weird things with it. We've got our all-in-one DVI feather. If you don't need the Pico shape, you want to use feather wings. But for those who have like a Pico or Pico W, this is like the right footprint. It uses 8 I/O pins for the red, green, blue, positive, negative, and then clock. It also has connections to the SCL, SDA, I2C interface through HDMI, which means that you can read the EDID on the monitor, which is good. You can see like what kind of monitor is attached, although you can only really output 640 by 480, which is pixel doubled 320 by 240. Still really fun. I mean, you can like now very easily do.
This is gonna be our show.
Displaying. Yes, we're in a fish tank. It's much easier now than ever to display to HDMI monitors. Used to be you needed an FPGA to do this, or like a VGA bitbank converter, whatever. All these demos work really wonderfully, easily, and like I said, CircuitPython support makes it super fast.
There are so many black rectangles in our lives that are off at all times.
Wouldn't you want them to have toasters?
It's like it's untapped canvas. It's art that you could make yourself and just put. So we're
video synth demo.
We're going somewhere where I know there's a screen. Like there's airports, there's bars, there's hotels. We're going to be staying somewhere soon. It's going to be at a hotel. I don't want to see what's on the TV. I do want to see something on the screen that I do.
That's right.
And so hotel TVs are the ones that like you.
Yeah,
I don't want the square there. I want to see this. I want this. This is what I want.
So one of the things like why not just use a Raspberry Pi? These are instant on, like they turn on instantly. You don't have to worry about a disk drive. They're solid state. So there are definitely there's analog inputs, and you can use like I2C very easily and connect like PWM and servos.
Here's a picture of the product. I guess I should say that one.
Oh yeah, this is what it looks like. So you will want headers to solder it into the Raspberry Pi Pico. We have some suggestions, and it uses a mini HDMI, just FYI, because the full size would fit. It like literally was not enough space. Yeah. But we have mini HDMI to HDMI adapters and also mini HDMI connectors available. So check this out. It's in the shop now.
Okay, and guess what? That is the price. All right, so here's what we're gonna do. We're gonna play 5 minutes-ish of new product well, kind of new products of Top Secret, and then put your questions in the Discord chat. Don't forget that's where we do them only. And then we'll see you on the other side, do questions, and we'll bounce. And then as a special treat, we went to like an LED art festival thing, so I'll play that. video at the very end while we're kind of straightening up here
Yeah.
after we're off live air. And then we also made a video that highlighted some of the Star Wars projects from May the 4th. May the 4th was last week. It wasn't during a show day, but I wanted to show the highlight reel because we have a lot of neat stuff. So I thought I should show both of those. So let's do top secret first, and then we'll do questions.
Look at Todd thing. That was
What? Yeah, that's good. All right, let's do some top secret.
Hi, Jepler here. I'm working on the latest improvements to the SynthIO module, which in CircuitPython 8.1 will have a whole slew of new features. And by the way, this stylish board is the Adafruit prop feather with an RP2040 and a dedicated I2C sound amplifier, among other goodies. Anyway, the next feature is called ring modulation. So first I'm going to play a sample without ring modulation, and then I will bring the ring modulation in. And so initially it's a fine tone, but it doesn't have a lot of life to it. But with ring modulation, there's just a lot of depth added to the sound with the interplay of those two waveforms. So look for these improvements in a pull request to CircuitPython coming soon.
All right, LadyAda, what is this?
I'm testing out this new I2S amp BFF for our Cutie Pie boards. This one has a Max 98357, which is an I2S 3-watt amplifier. I love it because it's just a couple passives, this chip, connect 3 pins to the I2S peripheral, and you're ready to go. And this is our Cutie Pie boards. You've got them in all sorts of varieties, SAMD21 and RP2040 and ESP32S3s. This is an ESP32. And what's nice is, it's got Wi-Fi, so when I connect this up, it's playing music, but it's not stored on the ESP. This is actually streaming an MP3 from Bandcamp. This is the album that we have here at Adafruit by Bartle Beats, and it's featuring Adabot and all of our electronic friends. So this is working really well. Streaming MP3s through I2S and then to this nice speaker.
Smallest streaming MP3 player.
Yeah. Beep, bop, boop, bop, bop.
All right, LadyAda, what is this?
This is me testing out a iSpy adapter I made for Cutie Pie boards. So Cutie Pie boards are our Seed Shout compatible microcontroller boards, and they come in all sorts of different configurations. We've got ESP32S2s and SAMD21s and RP2040s and all that good stuff. This one happens to be RP2040. And this is an iSpy adapter. So on the back, there's all these jumpers in case you want to change the configuration, but it has all the pins necessary to connect to pretty much all of our display boards. So you can connect to the SD card, SPI, I2C, IRQs, and all that good stuff. And there's no soldering required.
You're just telling me this tiny thing is driving this thing here.
That's right.
Okay.
Yeah, there you go. So coming soon to the Adafruit shop makes it so easy to connect displays.
All right, LadyAda, what's this?
This is me testing out our new Prop Maker Feather. It's an RP2040 feather, so it's actually running off a battery right now, although you can run it off of USB, program it that way too. It's got 8 megabytes of flash, the RP2040 STEMMA QT, and it's got a bunch of cool accessories like an I2S amp, an accelerometer, and pre-soldered terminal blocks to make it really easy to make props. So for example, 3 of the pins here are for NeoPixel, and this is 5 volts. And it's even level shifted 5-volt output. And then here's a switch input, and I can test that all the LEDs turn white. That's what my code's doing. And then I've got that I2S amplifier, so I can have this play audio clips. And these are stored on the RP2040 and the 8 megabytes of flash. And with the I2S amp, the audio sounds really good.
All right, LadyAda, what is this?
This is me testing out the Prop Maker Feather, but this time, instead of testing it, before I was testing it in Arduino, this time I'm testing it in CircuitPython. So I've got some LED animations going on here, and then I have the accelerometer changing the angle of the servo, so testing the servo and the onboard accelerometer as well. This is the servo port over here. And then I'm also testing out I2S and the mixer capability. So what's really cool about CircuitPython is it has really good audio support. And so, for example, I can read this potentiometer and use that to adjust the volume through a digital mixer, so you get like really good quality. And of course, you can mute, fast forward, play different tracks. So, I can move it up and down and do digital volume control. So far everything's working out really well. I've tested pretty much everything on this board and it's ready to get ordered and put into the Adafruit shop.
All right, LadyAda, what is this?
This is an A&O style rotary encoder. It's got this like clicky wheel and then 5 directional buttons, up, down, left, right, and center. It's kind of reminiscent of classic iPods, and it uses a lot of pins. It has 11 pins for all of the bits and pieces that are built into this navigation switch. So I designed this STEMMA QT based board that will basically do everything you need to control and read it over I2C. And here's the tester. So it's got all the pogo pins go into all the pads required, and this is a Metro M0 running our UPDI uploader code. So I will place this like so and reset it. And it connects over UPDI to program the onboard ATtiny 816, and it finishes in just a few seconds. This is now ready to test the rest and get into the Adafruit shop.
All right, I posted this photo. This is you and our kiddo in front of your computer. You're designing stuff. The joke that I'll probably keep doing for a little while is AutoCAD is now charging LadyAda 2 seats because 2 people are designing hardware now. Here's kiddo and a little snack. And every dude is complaining on Twitter about stuff or just being a jerk. We're shipping hardware, open source hardware, and this is for the Circuit Pirate. This is probably going to be a pretty popular product. We're going to release it into the public domain. And also, breaking news, July 26th, we're going to do a hack chat with Hackaday about the Circuit Pirate. We posted up a little bit about what's going on with Lady. I'll talk about it in a second. I had some graphics that we didn't really get to use for a pirate radio thing that we were going to do. So I revisited these. I'm working with our designer, Bruce. Here's some ideas for the logo. I like the little, pirate hat looking one. I also like the little circle thing. And then there's also this. So we haven't decided on the logo yet, but LadyAda, what is the Circuit Pirate?
The Circuit Pirate it's a revisit of a very old project where I wanted to try remaking the Bus Pirate, which is a very popular bus twiddling tool, kind of like a multi-tool Swiss Army knife for electronics, that was designed by Ian Lesney of I keep saying that wrong. Sorry, Ian Lenné of Dangerous Prototypes. And it was over a decade old. This is designed I think in 2010. It was very popular, but unfortunately was recently I think discontinued until further notice because of probably component shortages. Although I'm not 100% sure why. But we used to stock it, and now we are not we're not able to get it anymore. And so I was like, this could be a good opportunity to revise the design and maybe kind of bring it up to date and redo it with an RP2040. So this is just a rendering. I like to do a 3D rendering, especially when there's big connectors, of what it might look like to have a RP2040 based, but still shape and pin compatible Bus Pirate board. And maybe we'll call it Circuit Pirate. We have to chat though, because Scott had some ideas for some naming stuff.
Really? Call something else?
Well, something similar maybe. But
Yeah.
we'll chat. But it'll still use the logo. Don't worry. And but
I kind of only have
you only have one thing.
I kind of only work. I do skull logos and skull shaped logos.
Skull shape.
Yeah.
It's skull logos and skull logo accessories are here. So it's got STEMMA QT, and it's got the boot and reset button. It's got a mode switch, so you can maybe have it turn off the REPL because it's going to be running again CircuitPython. But the pinout is compatible. And a lot of the work I did was just trying to make it fit in a non 5 volt compliant board. Anyways, more coming soon. You can see a chat about it on Desk LadyAda. It'll probably be on a couple Desk LadyAdas.
Okay, that's our giant top secret section this week.
Don't ask. It's not out yet.
All right, let's do some questions.
Let's kick it.
Yeah. You're gonna read these off. I stored them up. LadyAda, hit it.
Okay. How do you feel about ESP32 firmware encryption to prevent theft from my consumer product? Is it even worth doing? I mean, I think that the encryption is now fairly good. I know Espresso has updated them with a bunch of engineering change orders, so I think the recent one does have fairly good encryption. However, there's really no way to guarantee. I mean, if you only have to make one mistake, right? Or your factory at least will make one mistake before the files are leaked. So just make sure that you have other protection like intellectual property protection for your products, not just assuming, basically assume that the firmware will eventually leak out. So what are you going to do when that happens?
I'm going to give you the short answer. It's not worth it. Build a community around your product. So there's the consumers who buy your product. They're never going to mess with it. And then you have like 1/10 of 1% of people that like to hack and mod. Empower them with documentation, with things not supported, not part of the warranty. Open source the code. Just make sure it's under a license that they have to retain, your name and credit you, and build a community. It's cool to build a business and a cause all at the same time.
Okay. Next up, I was wondering if the CAN bus card can talk to OBD2. Yes, it can. It doesn't. We don't publish a decoder, but it is pin compatible with ODB2, which is CAN bus.
Okay, next question.
I can't wait for the prop feather. Is there ETA for it? There's no ETA, but hopefully the next couple weeks.
Okay, next up.
When microcontroller boards say they have, for example, 3 UARTs, does that mean they can do 1.5 bidirectional serial ports or 3 of them? 3 UARTs usually means 3 full RX and TX pairs. Note that USB is different. There's usually specified by endpoints, and usually you need 2 or 3 endpoints per interface. So that's a little bit trickier, but UARTs is receive and transmit. And then how many watts might that Cutie Pie I2S amp be? It sounds great. It's a 3-watt amplifier. It uses the Max 9857A. I think that's the right part number. It's a 3-watt amp. We have the default be 9 dB. It does a pretty good 3 watts. And then, of course, you can do digital volume control as well.
Okay. If any of our questions sneak in before we go, we might get to them. But them's the questions. Oh, there is one. It just came in at the second. Maybe you're gonna answer this last one.
Okay.
While I get ready for the next.
On the way out.
Okay. Lady Ada, here is the question.
Okay. I understand physical distance is an issue with I2C sensors. What would you recommend for a newbie looking to reading sensors or controlling things around a body-sized object? Yeah, that's definitely body sizes. Can be about like 6 feet, and then of course things can go around. One is to have whatever you're doing centered, so you don't have like one long strand that goes up and down everywhere. You have maybe like the microcontroller in the center, and then you have strands going out, so you can, because that will not. It's the total length from the center point that's going to affect the capacitance. Second, take a look at, we have active retransmitters and active terminators, and those will always get you like really nice, clean I2C signal strength. So, a couple feet you should be able to do, but you may not be able to do it 1 megahertz. Stick to 100 kilohertz. Use an active terminator and active retransmitter. Those should definitely help.
Okay, don't forget the code is DVI Bell. Thank you so much, everyone, for joining us this week. At the very end of this, while we're tearing down the green screens and setting up for baby time, you can watch 2 videos that I'm just going to have playing. One is the spring showcase here in New York City, which is a bunch of LED art, and then a kind of a reel of some Star Wars projects that we've done over the years, celebrating May 4th that just happened last week. This has been an Adafruit production. Special thanks to Jessie May doing stuff behind the scenes. Do you want to do one last one? You got one last one. One just came out. I feel like we should do it. There you go. This one.
Whoa. Would the RTS line of a CH340 connect to the reset line of an AT Tiny or something else go between? Probably not. You would, unless you wanted to turn it on or off. I wouldn't connect to RTS because it can toggle while you're using it, like when you open the port. So you can look at the Arduino to see how they use a capacitor to use reset, but only like when it actually toggles fast enough.
All right. Good save. We got all the questions. See everybody next week. Here is your moment of Zener.
Bye, everybody.
No, I'm just helping out. But if you want to learn more about the artist.
Hi, I'm John Park, and this is a Chewbacca mask. Today I'm going to show you how to replace the audio so that we're not listening to the standard old Wookiee sounds, as nice as they are, but instead be able to replace them with any sound effects that we want.
Hey, what's up folks? In this project, we'll show you how to build a lighter prop using Adafruit's Prop Maker. This is fully 3D printed and has a collapsible blade. It's made from segments that are tapered so it can retract. So it makes a pretty cool effect when you swing it around. All of the electronics are housed inside the 3D printed hilt. It's also got an accelerometer for motion activated sound effects. It plays different sounds for swings and hits. They're also randomized and feel pretty responsive to your motion. The blade is removable and the hilt makes a pretty sweet flashlight. Inside the emitter is an insanely bright 3-watt RGB LED. In this video, we'll show you how you can build your own, so get ready to do some 3D printing, electronics, and programming. The code is written in CircuitPython and available to download on GitHub. It uses Adafruit's CircuitPython libraries to program the hardware. With the Adafruit Feather, you can easily upload code over micro USB and recharge the battery. So if you're a prop builder looking to program lights and sounds, the Featherwing platform makes it much easier. Hey, what's up folks? In this project we're building the Darksaber from The Mandalorian. This is a fully 3D printed prop that we designed to be a DIY kit that you can build yourself with electronics from Adafruit. The blade is entirely 3D printed and has strips of NeoPixel LEDs embedded inside. It's built to be durable so you can throw some heavy swings for those intense photo shoots. All of the electronics are hidden inside the hilt and it features motion activated lights and sounds. The hilt is designed to look like the Darksaber from Season 2 of The Mandalorian. For the electronics, the prop maker Featherwing is designed for making props with lights and sounds. It's great for portable projects that need motion sensing, buttons, and powering lots of LEDs. Be sure to check out the Learn Guide for a full step-by-step tutorial on building this project. It's documented with plenty of photos, so it's easy to follow along and get started. You can pick up the lightsaber kit now from Adafruit and build awesome props with open source hardware. Thanks so much for watching, and don't forget to make the Force be with you. Hey, what's up folks? In this video, we're making a prop from Star Wars, The Book of Boba. We were inspired by episode 3 of The Book of Boba. The chief of the Tusken Raiders yields a staff that we thought would be really cool to remake. We designed and 3D printed several pieces to make the staff. We printed them in different colors so they're ready to go right off the printer. They can be printed without any supports and they don't need any screws or glue. Each piece features a threaded connector, so it's really easy to assemble and take it apart. We hope this inspires you to get creative and make your own props from your favorite TV shows or movies. Thanks so much for watching, and don't forget to subscribe for more projects from Adafruit.